In this video, we'll start writing the more sophisticated kind of tactics where we're working not with syntax but with expressions. So first, a quick view of what a tactic is. Intuitively, we think of it as something that modifies a tactic state, and the reality is not very different from that. A very simplified view of this is that you can think of tacticam as a state monad, which means you have a state in the background which can be managed automatically with nice syntax. So this means that if you have an element of type tacticam alpha, it's a term of type alpha, but not quite. It depends on an initial state, and also in calculating it, you modify the state, so you return a final state as well. So it's essentially a term of the type tactic.state to alpha.tactic.state, and tactic itself is an element of type tacticam unit. Since unit has a unique term, returning a unit has no information. So all that happens here is that the state gets modified. And that's what we think of intuitively as tactics are doing. Okay. So just some quick examples of methods that we'll find useful. The main target is the type that we are trying to prove. Okay. So this is something of type tacticam expression. That means that it has it returns an expression that depends on the state of the tactic. Of course it does, because the goal depends on the state of the tactic. Get main goal. The main goal is not the type, but instead what's called a meta variable representing it. Useful way to think of meta variables is more like variables in algebraic equations. That is, unknown things, they're placeholders to which you have to assign values. They are not variables in the sense of a programming language, really. Okay, there are unknowns to which you have to assign things. You can assign things. Those assignments may involve meta variables, and they have to be assigned, etc. We will see many examples of this. Couple of other useful methods. You can get all the goals, and you can also set the goals. Okay, so here you're returning tacticam unit. So the previous ones all gave you information. This gives no information because a unit has no information. Instead, it changes the state by setting the goals. Okay, the names tell you obviously what it does. So let's try to abuse our power a little bit. So we know we can change the state. So let's have a tactic which just closes everything. Okay. So first of all, this is the syntax. Previously we had a macro. Now we have the word elab. This means we have to return an expression. Okay. But if we are returning tactic, it's actually we return nothing. The tactic takes care of this behind the scenes. Okay. So let's set the goals, and remember what we have to set them as. We can set them as nothing. Okay. So nice and simple. Let's try to prove something using this. We have great power. We can prove everything using this. Okay. So we will disclose the goal. Well, unfortunately, what we end up is we do end up with no goals. So this view is nice, and if this was the old lean 3 style, you would get your reward as well. But you have a line here. It says kernel declaration has meta variables. So you have a low level error. Okay. So the first moral here is that when you do beta programming, you're responsible for a lot more things. You don't have a type system that protects you like you do in lean, at least not even to a remotely the same extent. Yeah. It's your responsibility to make sure the states are valid and so on. Lean prevents the global environment from being messed up. So you could not give an invalid proof into the global environment. All that, but you'll get a low level error when that happens, and it's worth understanding what is this low level error. You see that I said the goal is a meta variable. It's something that has to be assigned. We just said it's no longer a goal without assigning it. So that's what gave us this low level error. So let's just close this and look a little bit at what we actually want to do. So now we do have a tactic in lean which does solve everything, and that is the sorry tactic. But the sorry tactic doesn't do anything silly like this. What it does is it uses an axiom called a sorry axiom. We check what that is. Given a type and a boolean telling you whether it's a synthetic sorry, whatever that is, it doesn't matter. It gives you a term of that type. Okay, so you can prove everything in using sorry axiom. So in the presence of sorries, of course, lean is not consistent, but sorries are detected and kept track of, etc., etc. So what we want to do in the sorry tactic is actually close the goal with a term that is built with the sorry axiom and actually has the correct type. Okay, and we'll do this, and as an exercise, let's do this with something which is an extension of sorry, a custom version. Let's call this a to do tactic. Okay, so I have a string which I will give it to this. So we often write sorry, but if you come back to the code, okay, so I have to say that this is a tactic. Okay, let me say sorry for the moment just to check my syntax. So I'm saying to do, and I'm giving it a string, and what I want to do is that I want to return a sorry, but very often we want to leave a message what that sorry was. Was it something difficult? Was it something trivial? Okay, was it something somebody else should be doing, etc. So let's put the message, let's log the message first of all. Okay, so message s. So we are logging the message. Okay, now let's get to our real work. So our real work is we want to create, I'll do this in a verbose way. We want to create an expression for the term that fills in the main goal. Okay, so for that, let's say let target as get main target. So many of these could be one-liners just to illustrate steps. So first of all, I've got target. Okay, so what is target? It's a term, but it's supposed to be a type, in fact, but it's just an expression. When you're working within meta programming, you do not have actual terms to work with. You're instead working with the expressions representing that term, which gives you a lot more power, but it's also inconvenient in many ways. Okay, so let's work on this. I want to create a term of that type using sorry axiom. Okay, so let's try to create the sorry expression, an expression using that. Okay, so let expression, sorry expression, let's call it. Okay, there are various ways of making applications, but I'm going to use a powerful way. Okay, this is monadic. We'll hover on it in a minute and see what that is. Okay, so I'm going to take sorry axiom, which is a name, and apply it to something. This is already valid code, but it's not correct code. So, but I put it there as a placeholder. So what it does is, given a constant name and an array, it fills in the applications. It fills in implicit arguments. Here we don't have implicit arguments, so we would be tempted to use one of the lower tech methods, but we do have universes. So if you do it in a naive way, you'll get silly errors involving universe levels. So instead, Lean provides us with these very nice methods. M is monadic. I like to think M is magic. It does lots of low-level work for us. Okay, so we want to apply sorry axiom. What are the arguments? We have to provide two arguments, even though there's a default. And the first one is a type. Okay, and we already have the type. It's target. It's an expression. Now the second one is we need an expression which is false. Okay, so remember sorry side, it's not a synthetic sorry. You could create a synthetic sorry here, no harm done. So what is sorry expression? Again, it's an expression. We secretly know, but it's our responsibility to know that it's an expression that is valid, type checks, and represents the type target. Okay, and so now what we can do is assign to the meta variable. So we close the main goal. So we have a term called close main goal. Okay, I'll just clarify here. There are two arguments here. The main one is the second one. I'll come back to the first one in a moment. Okay, so what is the main argument? So we close main goal, which means you will see here it closes main goal using the given expression, and by default it checks that we haven't done anything bad. We closed it by an expression actually of the correct type in closing it. Okay, so we have to construct, we can close it. If we use something invalid, we'll again get a low level error. Okay, what is this to do? This is actually the name of the tactic. It came in a recent Lean version. A few weeks ago, Lean did not have it. This is a tactic name only for logging errors and such things. It is not a recursive call to do. So this is just the name. The tactic is not called, it's passed as a name just to go in messages, nothing else. So you can ignore it. So what we have done is we have written a tactic which closes the main goal with an expression. We have learned to construct expressions using using this monadic method, make appm. There's a bunch of very useful ones which handle things. And let's now prove something. 3 is less than or equal to 15, colon equals by to do, and I can figure out what I should be doing. So here's a message, figure out what I should be doing. Okay, so it's a custom version of sorry. So we have seen our first tactics. These are again, you start with elab, give the tactic syntax, and then you are supposed to return nothing. We didn't explicitly return anything at all. That happens at the end of the tactic. We may use return if we want to return at a middle point, and we use really just helper methods to handle our goals. Okay, we will go on and look at more and more sophisticated examples as we go along this series. Unfortunately, even a tactic of this complexity can give a low-level error, and a strange looking one. We'll come back to what that strange looking error is a little bit, but first let's know how to fix this. Well, this recipe is very simple. When you begin a tactic, you should always begin with main context do. Okay, and you see that thing miraculously went away. So just as a quick explanation, what we had there was a missing free variable. What happens is free variables and lots of declarations are all part of the local context. And you in metaprogramming, you can have it's part of the state. So you could just have the wrong state. So with main context tells you that you are going to use the goals local context, and this is the main goals local context, hence it's called with main context. More generally in meta, sometimes you have the main context of a meta variable. Okay, so with that fix, this is correct, but the final lesson of this is always begin your tactics with main context do. Well, I violated that for evil, but the evil tactic is rubbish anyway, so it doesn't matter. If you want to write your tactics correctly, begin with main context so that all your variables are correct.